Hi, this is Mrs. Rodriguez with another lesson video. Today we're looking at compound events for either or probabilities. So, compound events are simple events where there is a combination of probabilities, meaning there's more than one probability at once. There are two types of compound events. The first one is either/or, which is what we're going to focus on today. An example of that would be you have one die numbered 1, 2, 3, 4, 5, and 6. So it's just a standard die. And you roll it. What is the probability of rolling either an A or a 6? Meaning, when you roll that dice, what's the probability that it'll land on either a 1 or a 6? Okay, that's an either or problem. The second type of compound event is a both and or followed by. Okay, this type of event we're going to look at in a separate video. But a both and followed by, an example of that would be you have two dice now, numbered 1, 2, 3, 4, 5, and 6, so just a standard dice. Except this time, when you roll the two dice, what's the probability of getting a 1 and a 6? So now we have two probabilities, but you have to get both of them. What's the probability of getting both? As opposed to the either or compound events, which we're looking at today, which is one or the other. The probability of one or the other happening. So let's go ahead and look at our first example. So for compound events that are either or, so one probability or another probability happening, what we need to do is you find the probability of each item and then you add them together. So you're going to add the probabilities together. So let's take a look at our first example. We have the die, again, numbered 1 through 6, and you roll it. What's the probability of rolling either a 1 or a 6? So we find out the probability of each one first. So the probability of getting a 1 when you roll a dice is going to be 1 out of 6. Each dice has 6 sides. Each side's numbered something differently, and there's only one 1, so 1 out of 6. And we write that as a fraction as 1/6. Now, the probability of getting 6. Well, once again, there's 6 different sides. There's only one number, 6, on the dice, so it's going to be 1 out of 6 again, which equals 1/6. Now that we know our two probabilities, we can go ahead and add them together. So 1/6 plus 1/6. Because they have common denominators, we can go ahead and just add these fractions. So remember, common denominators mean that the numbers, the denominators of each fraction are the same. And when they're the same, we can go ahead and just add them together. 2 out of 6 can be simplified because 2 goes into 2 and 2 goes into 6. 2 goes into 6 one time. Or I'm sorry, 2 goes into 2 one time, and 2 goes into 6 3 times. And we get an answer of 1/3. If you need a refresher on how to add fractions, go ahead and look up that video. Moving on. Here's a second example of a compound event. What is the probability of spinning and getting a star on spinner A or spinner B? So we have two different spinners. We just want it to land on a star if you spin both, and it can either land on a star on A or B. So once again, we have to find the probability of each first and then add them together. So what's the probability of getting a star on spinner A? Let's see. Well, first of all, we have 1, 2, 3 stars. So there are 3 stars on spinner A. And now we need to number the parts, the total number of parts of spinner A. So we have 1, 2, 3, 4, 5, 6, 7, 8. So out of the 8 parts on spinner A, 3 of them have stars. So it's going to be 3 out of 8 or 3/8. All right, let's take a look at spinner B. In spinner B, we have a lot more parts to it, right? So let's go ahead and number the parts first. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now we have 16 parts, okay? And out of those 16 parts, we have 1, 2, 3, 4, 5 with stars. So it's going to be 5 out of the 16 parts have stars. Now we add the two probabilities together. So we have 3/8 plus 5/16. Notice the denominators are not the same, so we cannot just add the two numerators together on top. We're going to actually have to solve it by getting a common denominator first or using another method. So let's go ahead and look at a couple of different methods we could use for solving these addition problem with two fractions. So the first way we're going to look at it is by using the traditional method. Now the traditional method is the method where you use the least common multiple and a giant 1. So the first thing we need to do is find our least common multiple. That will tell us what our denominator is supposed to be. So I'm going to find the first 4 multiples of 16 and 8. So times 1, times 2, times 3, times 4. Okay, and we're going to do that for 8 and 16. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. Now I find the multiples for 16. So 16 times 1 is 16. And you know what? I actually don't even need to finish my chart because remember, we're looking for numbers that they have in common. And right off the bat, I can see that 16 times 1 is 16, but I also have a 16 here for the 8 under times 2. So that means our denominator is supposed to equal 16. So I'm going to take my two fractions, 5 out of 16 and 3 out of 8, and now I know I'm going to have to multiply by a giant 1 where it equals a fraction that has 16 as the denominator. So let's take a look at 5/16 first. What times 16 gave us 16? Well, it was 16 times 1. And because this is a giant 1, that means the top number of this fraction also has to equal 1 because 1 divided by 1 equals 1. 5 times 1 is 5, so we end up with 5/16. For 8, what times 8 gave us 16? Well, 8 times 2, so that means 2 goes on the bottom of our giant 1. And if 2's on the bottom, that means 2 needs to be the number on top as well because giant 1 has to equal 1. And 2 divided by 2 is 1. 3 times 2 is 6. So now I have my two new fractions. We have 5/16 plus 6/16. And we can go ahead, because we have a common denominator now, add the top numbers or numerators together and get 11 out of 16. And that's our answer, 11 out of 16. Okay? Now, did you have to use the traditional method? No. We could have also used the butterfly method. Now, the butterfly method is where you multiply the numbers across from each other and you multiply the two denominators together. So it looks like this, and I'll use different colors so you can see where I'm getting my numbers from. It's going to be 5 times 8 plus 16 times 3 all over 16 times 8. Okay, so when we do the butterfly method, That's what we get. Now, all we have to do is multiply everything out and then simplify. So 5 times 8 is 40. 16 times 3 is 48. And 16 times 8 is 128. So we've multiplied everything out. All we have to do now is simplify. So 40 plus 48 is going to be 88 over 128. I happen to know that both 88 and 128 are divisible by 8, and you end up with 11 out of 16. However, if you did not know that, that's okay, because what you could do is, since both numbers are even numbers, the 88 and the 128, and I know they're both even numbers because for even numbers, you look at the very last digit, and if that digit's even, that means the whole number's even. And 8 is an even number. So anytime you have an even number, you automatically know that it's divisible by 2. So start with 2. 88 divided by 2 is 44. 2 goes into 8 4 times, so it's going to be 44. 128 divided by 2, well, 2 goes into 12 6 times, and 2 goes into 8 4 times, so we're going to get 64. Once we're here, we can go ahead and divide again by 2, because notice 44 ends in 4, 64 ends in 4. 4 is an even number, so we know that 2 goes into both. 2 goes into 4 2 times, so 44 divided by 2 is going to be 22. 2 goes into 6 3 times, 2 goes into 4 2 times, we get 22 over 32. Once again, 22 and 32 end in an even number, so we can keep going dividing by 2. 2 goes into 22 11 times, 2 goes into 3 1 time, and 2 goes into 12 6 times, and we get 11 out of 16. All right, so if you're unsure of what divides into the number evenly to simplify, go ahead, and if you know it's not a number, just start with 2 and keep dividing by 2 until you can't anymore. 11/16, 11's a prime number, so we're done. We can't simplify it anymore. All right, so that's the butterfly method. We could have also done the diagram method, which means we draw a diagram. So we have 3/8, so I'm going to go ahead and I'm going to color in. We have 2 identical rectangles, right? The first one's been divided into 8 parts. So I'm going to go ahead and color in 3 of the parts because it's 3 out of 8. Our second rectangle has been divided into 16th parts because it's 5 out of 16, right? So I'm going to go ahead and color in 5 of the parts because it's 5 out of 16. And one more. Okay. Well, the 2 rectangles are divided 2 different ways. One's divided in 8, one's divided 16 times. And as you can see, one of the 1/8 is much bigger than one of the 1/16. So that means they're not equal to each other. 1/8 is not equal to 1/16, so we can't just say we have 2, right? We can't say we have 3 because we have 3/8 and 5 because we have 5/16 and just add them together and say we have 8, because one is bigger than the other. They're not equal to each other. So we first have to divide up our rectangles so they have the same number of parts. Once they have the same number of parts, then we know that each part is equal to each other. So let's go ahead and do that. All right, so the first rectangle has been divided into 8 parts. The second has been divided into 16. 16 parts is more than 8 parts, so I need to divide the 8 to make more parts, and we're going to keep dividing until both rectangles have the same number of parts. So I just divided the left rectangle in half, and now if I were to count the number of parts, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now it has the same number of parts as the rectangle for 5/16. So because they have the same number of parts now, I can add them together. So when I add them together, obviously the rectangle needs to have 16 parts because that's how many parts match in both rectangles. And we take a look at our first rectangle and we notice that 6 of them are colored in. So that means I'm going to color 6 parts in my answer. So 1, 2, 3, 4, 5, 6. In our second rectangle, we're adding 5. Okay, so I'm going to add 5 more. 1, 2, 3, 4, 5. Now all I have to do is count how many parts are colored in. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that means that our answer is 11 of our parts are colored in out of 16. So our answer is 11/16. Okay, so that was the diagram method. Now, do you have to use the diagram method? Or do you have to use the butterfly method? Or do you have to use the giant 1 method? No, remember, I'm showing you different ways of adding fractions, right? I'm teaching you different tools you can use. It's your job to pick which tool works for you. Okay? And as always, if you have any questions or need additional help, feel free to make an appointment with me for office hours. Hope you have a great day. Bye.